Hello children, myself Mrs. Romaputran, teaching in standard 10 from Srimati LPSAVANI VIDHYABHAVAN. Children, we have already started with chapter number 1, real numbers. Today this is our second session of chapter number 1. We are going to start with exercise 1.2, question number 5. Question number 5 is, check whether 6 raised to n can end with the digit 0 for any natural number n. Children, you all know, to end any digit by 0, it should be divisible by 5. That means one of the factors should be 5. Now we know 6 raised to n. That means 2 raised to n multiplied by 3 raised to n. Now 2 raised to n multiplied by 3 raised to n. That means factors are 2 and 3. While we want factors 5. Therefore, 6 raised to n can never end with the digit 0. Question number 6. Explain why 7 into 11 into 13 plus 13 and this are composite numbers. Children, you all are aware about composite numbers and prime numbers. 2 or more than 2 factors are known as composite numbers. Here you can see, here multiplication is there, here plus is there. So taking out 13 as common, we will get 13 multiplied by 78. Factors of 78 are 2 into 3 into 13. That means total factors are 2 into 3 into 13 square. More than 2 factors are there, therefore it is a composite numbers. In the same way, here 5 is common. Taking 5 as common, we will get 5 multiplied by 1009. Here children, you can see 2 factors are there, therefore it is a composite number. Turning to question number 7. Question number 7 is, there is a circular path around a sports field. Sonia takes 18 minutes to drive one around the field while Ravi takes 12 minutes for the same. Suppose they start at the same point and at the same time and go in the same direction. After how many minutes will they meet again at the starting point? That means after minimum how much time they are going to meet again. As the word minimum is there, so we can understand that we have to find out LCM, that is least common multiple. Minutes are 18 and 12. Factors of 18 are 2 and 2 multiplied by 3 square. Factors of 12 are 2 square into 3. So LCM is equals to 36. So therefore both Sonia and Ravi will meet again at the starting point after 36 minutes. Next, exercise 1.3. Question number 1 is, prove that root 5 is irrational number. Suppose we want to prove that it is irrational number, so its opposite we will suppose. As for example, we have to show that it is irrational number. So we will suppose that it is rational number. After showing that it is a rational number, we will show that as we have shown rational number, it is incorrect. That means our supposition is wrong. How to show it? First of all, we will suppose let root 5 be rational number. Children, you all know that rational numbers always can be written in the form of a upon b, or we can say p by q. So here root 5 is equals to a upon b. Division becomes multiplication. So it is root 5b equals to a. Taking square on both the sides. So by taking square on both the sides, we will get 5b square is equals to a square. Taking this 5 to the right side, we will get 5 divides a square, 5 divides a. Children, in this question, few steps you have to memorize. Whenever we have to find out that root of prime number is irrational number. Now that means 5 divides a square, 5 divides a. Now we have to suppose let a equals to 5c for some integer c. Now a equals to 5c. So here in place of a we are going to write 5c. So taking square, we will get 5b square equals to 25c square. By cutting, you will get b square equals to 5c square. This 5 if we take to the left hand side, what it becomes? It becomes 5 divides b square and therefore 5 divides b. Children, here you can see that a and b have at least 5 as common factor. Why 5 as common factor? Because here we can see that 5 divides a and 5 divides b. So we can see for a and b both are having 5 as common factor. Now therefore, whatever we have supposed that it is rational number, that supposition is wrong. Therefore our supposition is wrong. Therefore root 5 is irrational number. Next question, prove that 3 plus 2 root 5 is irrational number. Here we will suppose 3 plus 2 root 5 is rational number. Rational number means it is in the form of a by b. Now children, what you have to do? you have to make separate this root 5. So by rearranging the terms, what we have got, root 5 is equals to a minus 3b upon 2b. Here you can see root 5 and here a minus 3b upon 2b. Here a and b are integers. That means a minus 3b upon 2b are integers. Therefore, it is a rational number. Now, this is rational number. So, root 5 also should be rational number. But we know that root 5 is irrational number. Therefore, our supposition is wrong. Therefore, 3 plus 2 root 5 is irrational number. Next question. Prove that 1 by root 2 is irrational number. Again here, in the same way, we will suppose 1 by root 2 be rational number. Rational number we write in the form of a upon b. Now here, so you can see by taking cross multiplication, 1 multiplied by b is equals to root 2a. Therefore, b upon a is equals to root 2. Here, a and b are integers. Therefore, b upon a is rational number. Now, if b upon a is rational number, that means root 2 also should be rational number. But we know that root 2 is irrational number, because root 2, that means root of any prime number is always irrational number. So, root 2 is irrational number. Therefore, our supposition is wrong. Therefore, 1 upon root 2 is irrational number. Next question. Prove that 7 root 5 is irrational number. What we will suppose? We will suppose let 7 root 5 be rational number. Again, now rational number means 7 root 5 is equals to a upon b. Now we want only root 5. So this 7 we will take to the right side. Multiplication becomes division. So this will become root 5 is equals to a upon 7b. Again here, a and b are integers. Therefore, a upon 7b is rational number. Now a upon 7b is rational number. Therefore, root 5 is also rational number. But we know that root 5 is irrational number. That means whatever we have supposed is wrong. Therefore, 7 root 5 is irrational number. Now, question 3, last sum. To prove 6 plus root 2 is irrational number, all these sums are of same type. Again here, we will suppose 6 plus root 2 is rational number. Now, rational number, that means a upon b. Now we want only root 2. We don't want 6. So this 6 we will take to the right side. So it will become plus 6 will become minus 6. So it will be a upon b minus 6. By taking LCM, you will get root 2 is equals to a minus 6b upon b. Again here, a and b are integers. Therefore, a minus 6b upon b is rational number. Now suppose if this is rational number, that means root 2 also should be rational number. But we know that root 2 is irrational number. Therefore, our supposition is wrong. Therefore, 6 plus root 2 is irrational number. Thank you very much children. Today this much only. Thank you everyone.